This is a demonstration of the interference problem between ILS systems on aircraft and 5G cells. This received a lot of news coverage a couple of years ago as more 5G spectrum was being licensed up in the C-band. So when we talk about C-band, we're up near 4 gigahertz. So 3.9 gigahertz in this case. That's the cell that you're looking at here. It's very high powered, and we want to see how this plays with a very low powered radar altimeter system that's on board an aircraft. Now, a radar altimeter system is over 200 megahertz away, higher up the spectrum, 4.2 gigahertz. It uses 50 milliwatts of power, so very low power compared with a 5G cell, and 20 megahertz of bandwidth. And we've actually modeled one here. That's the little circle here. So this is 100 meters altitude looking straight down, and this is used by the computer to gauge the height in zero visibility. So you hear people talk about a cat-free ILS approach. That's zero visibility under computer control. So it's very important the computer is measuring the ground accurately. So what we're going to do is model that cell versus a radar altimeter, and it's on the flight path. Not a great place to put a cell. So we're going to pick the altimeter as our signal of interest, and the noise source is the 5G tower. Using the interference API at CloudRF, we can see the result. If it's green, it's good. So this is where the altimeter is functioning and it has a clear signal. As we near the cell, we start to experience interference from the powerful cell. And you can see it creeps in on the periphery of the signal. Where the signal is weakest, that's where the 5G signal is able to dominate, despite being over 200 megahertz away in the spectrum. It can't dominate directly underneath because that's where the altimeter is slightly more powerful, and also the cell has a very directional antenna pattern. These are antennas designed to serve handsets on the ground, not handsets in the sky. Once we're clear of the cell, the signal is cleaner, and we're able to measure the ground height accurately with a nice clean signal. So why do they tell you to switch your phone off? Well, a modern 5G cell uses beam steering. It's not just the same power in all directions, it flexes the power to meet demand. If several hundred handsets all of a sudden appear in the same location demanding service, a beam will likely get steered towards the plane. It won't get steered up because they have tilt limits on these, because you shouldn't be serving handsets in the sky for all sorts of technical and commercial reasons. So the risk is very low. This is an extreme example we've modeled here. We've used the maximum power parameters. This is as bad as it could get. Also, the sighting here at the end of the runway is a terrible sight for a high-powered C-band cell. But the risk is still there. It's very low, but you can help the pilot in an ILS landing by following instructions and keeping RF noise to a minimum.